Well, guys, this is Guruji Online, and today we have come a couple of JEE Advanced problems. One of the problem that has come in 2012, that is before your screen. It says two large vertical and parallel metal plates are separated by a distance 1 centimeter and connected to DC voltage source of potential X. Now a proton is released at rest midway between the two plates. It is observed to move at an angle of 45 degrees to the vertical. So first of all, let us make the diagram. Two parallel plates are there. And there is a potential difference between these two plates, that is X, that is potential difference. Suppose this is at positive and this is negative plate. Then of course, if you release some proton, then what the question is saying, it is moving at an angle of 45 degree to the vertical. Like this is basically moving like this. And this is your vertical. And this is 45. We have to find out the value of the X. D is the distance, suppose. Then what is the electric field between these two plates? That is X by D. Correct? Now this proton, it is having mass also. So there will be a force, gravitational force acting on this mg, and another force will be electrostatic force, and that will be your Q into E. I hope this is clear. And 45 degrees there, since it is making an angle 45 degree, that means what? That means these two forces, they are equal. Or we can write it as X upon D. Or here we can find out the potential difference, and that will be equal to mgd upon Q. If you put the values, then you have mass of the proton, of course, G. Then we have 1 centimeter, D is given 1 centimeter, that is 0.01 meter, divided by your 1.6 into 10 raised to minus 19, that is the charge of the proton. And this X will approximately come to 10 raised to minus. So here our answer is, I hope this question is clear. Correct? Now we will go to the next question. A wooden block performs SHM on a frictionless surface. You have a surface, suppose some wooden block is there. It is performing SHM. Suppose this is your point O. With frequency mu zero. The frequency mu zero is given. The block carries a positive charge. Of course, what will be the frequency? This frequency will be 1 by 2 pi root K by M, where K is basically split constant and M is the mass of the ball. So it is performing an assembly. Now, the block carries a positive charge, so it carries a positive charge on the side. If a uniform electric field is switched on, the uniform electric field is given like this. Then the SSM of the block will be like this. We have to find what is the correct answer. So when the mean position is without electric field, it is mean position is O. When electric field is on, then what will happen? It will experience an extra force of Q into E. Due to that, this block will shift. Now, this will become the main position. Suppose this shifts x0 distance. This x0 distance shifting is basically due to this electrostatic force. That means QE is nothing but K into x0. Or you can say x0 is nothing but QE upon. Now, after putting on the electric field, suppose if we shift this block some more distance, x distance, and if we leave it that, what will happen? It will start performing the SHM, and now the mean position will be O dash. Correct? So here our Newton's second law says m d square x upon dt square. That will be basically minus k x plus x0 minus plus of course q into. You can put the value of q into E, then it is again, and of course frequency will be mu zero only. So here let us see the answers of the same frequency with shifted mean position. Yes, I think this is the correct answer. With the same frequency, the same mean position, no, it is not. Of change frequency, no, frequency is not changing. Of change frequency is not changing. So it has only one correct answer. Let us go to the another problem. This is the problem on your screen. Consider a system of three charges Q by 3, Q by 3, minus 2, Q by 3. placed at points A, B, and C respectively. Take O as the center of the circle, its radius R. Its radius is basically R. Then there are a number of options are there we have to find. Electric field at O is Q upon 8 pi epsilon 0 R square, directed along the negative axis. Directed along the negative axis. Now here you see A and B, they are of the same magnitude and sign. So due to A and B, the electric field at O will be 0. Correct? So electric field at O will be only due to the charge at C. And what will be that? That will be basically, you can say E0 will be, and of course that electric field will be directed towards negative axis. So we can say it is minus, it is K 2Q upon 3 upon R square. Since this is minus x-axis, you can write it as like this. And this will be equal to minus Q upon 6 pi epsilon 0 R square. Here it is given, so this is not correct. Now, potential energy. Let us see what is the potential energy of the system. So, we have three charges. So, potential energy of these charges will be basically U will be equal to 1 by 4 pi epsilon 0. Then, of course, we can write it as QA, QB upon RAB plus QB, QC upon RBC plus QB, QC upon QA and QC or RBC. For finding out potential energy, we have to find out RAB, that is, it is 2R, RBC. RBC we can write it as AB into cos 30 degree. Sorry, RBC. It is RBC, and this is equal to R2R into root 3 by 2, and this will be equal to RB3. And what about RAC? RAC is nothing but 2R into cos 60 degree, or you can say it is R. Now we know all the parameters, so we can write it as potential energy 4 pi epsilon 0 and QA, QB, that is Q square upon, this will become again R minus RBC is your R is 3, and this will become 2Q square upon 9 2QR, and of course this will also be minus 2Q square upon 9R. And you can calculate the value of this, but this is not zero. This is not zero. So potential energy of the system is zero. This is also not correct. Magnitude of the force between charges C and B. C and B. Magnitude of the sector. That we can find out. Magnitude of force between the charges C and B is nothing but 1 by 4 pi epsilon 0 QB QC upon R square BC, and you know 1 by 4 pi epsilon 0 QB and QC. What is QB and QC? QB is Q by 3 and minus 2. So this is basically, we are finding out the magnitude. So it is Q by 3 into minus 2Q by 3 upon RBC is basically your, we have find out your R root 3. So here it is R root 3 square. So that means 1 by 4 pi epsilon 0 into 3 into 3 into 2 into 3 divided by Q square upon. So here it will come, this will come around Q square upon 54 pi epsilon 0. And here, what is there? It is 1. This is correct. Potential at O is, let us find out the potential at O. What is potential at O? Potential at O will be nothing but, we can write it as V is equal to V at O will be equal to 1 by 4 pi epsilon 0. And here Q by 3 into or you can say into R. Then another charge is minus Q by 3 into R. Sorry, this is plus, then minus 2Q by 3 into R. And this will become basically 0. The potential actually at O is 0. So this is also. So here you have seen this problem was very easy, but to solve it, it will take a little more time. But if you are ready with your concepts, then there is no problem in solving JEE Advanced problem also. As you know, Guruji Online brings time to time to you a lot of JEE Advanced real-time questions. So, how was this video? Please do share with us, subscribe my channel so that whatever problems we are going to come in near future, you should not miss that.